Hello, I'm Carol Gunst, Marketing Director at AtScale, and I want to welcome you to this month's Office Hours webinar. Today we feature AtScale founder and Chief Strategy Officer Dave Mariani, and our topic is AtScale Adaptive Analytics and AWS. All participants are in listen-only mode. If you have any questions as we go along, please type them in the appropriate box and we'll get to them at the end of this webinar. Now, before I hand it over to Dave, let me start with a quick poll that will help us focus on some topics that you're interested in for future Office Hours webinars. We'll give you a minute to make your selection and then we'll get started. Thanks for your help there on the poll. And now, Dave, over to you.
Thanks, Carol, and hello, everybody. Today we're going to have I think, a fun session where we're going to show you how we can really, truly use and exploit the AWS infrastructure for analytics, not just Redshift, but also S3 and even things on-prem. So today this is what we're going to do. A little bit about AtScale, what we do and how we do it, where we fit in terms of the architecture when it comes to your cloud data stack. A little bit in more specifics about the AtScale architecture in particular, and how we do what we do. Talk about a little bit about case studies and what we have done for some of our customers, especially customers in AWS. And then we'll spend most of the time with a full-fledged demo. So I'll show you everything we can do and how we do it. So just to start with, what does AtScale do? We really help customers in these 4 areas. First is to accelerate data-driven decisions. And what does that mean? That means getting rid of all that prep time that you normally have with preparing data for analysis, and making that as quick and instantaneous as possible to get the data into the hands of the users. Not just the first time, but also allow them to change it and morph it and add to it without the traditional cost and life cycle that you see with data pipelines. We definitely help our customers control their cost and really limit the complexity of their analytics environment. Things have gotten so much worse in terms of complexity these days. While the cloud has simplified a lot, it's now introduced another dimension of complexity, location, and that presents real challenges for the business analyst to know even where the data is and not just have to know where it's stored. Also, when it comes to compute and the new pricing where the cloud is charging by compute, that can get really scary in an analytics environment where you have your business users running queries that may be unbounded, which make it very difficult to control costs. And so we help customers to be able to get predictable costs and also really simplify their analytics environment. One consistent view, look, it's single source of truth. This is a primary reason why I started the company with my rest of my co-founders in 2013. You know, at Yahoo, I had 5 different BI tools, all with different data pipelines. And at the end of the day, guess what? I had 5 different versions of a page view. And that was just unacceptable to have such a basic metric be different in every different tool that was being viewed and used. And then finally, the risks. You know, we live in an environment where a data breach or even just data being seen by the wrong individual could have huge consequences for the enterprise. You can't have data walking around on laptops. So this whole data movement, data copy kind of traditional life cycle that we've seen when we're supporting analytics, where we're creating data copies, where we're allowing data extracts and storing data on laptops, it's just not acceptable anymore. And so we really help customers by keeping the data where it landed, and query that data in place so that data is never being copied or moved or being stored on people's machines. So the way that we do that is with really these four main feature areas. What we call intelligent data virtualization. What intelligent means is that we're going to be really smart about how to make data virtualization work at scale. So whether your data is on-prem, in the cloud, in a lake, or in a data warehouse, we're going to present that to your business users, and they're going to be indifferent about where it came from. And in fact, they're not going to know where it came from, which gives you and IT and the enterprise the most flexibility to store the data where it makes the most sense. The universal semantic layer. This is how we deliver a single source of truth. And you can't do that unless you support all protocols for query. Excel still is the #1 BI tool on the planet. And we can make Excel a great visualization tool with all the controls that you want and need by doing live pivot tables using Excel and not using Excel as a data dumping ground. We call it autonomous data engineering. Everything that you have to do today to support analytics involves a data pipeline, making big data small. We're gonna make analytics and big data analytics scale, but we're gonna do that behind the scenes for you. So by studying and looking at people's query patterns, our engine and our heuristics and our AI will automatically create the necessary data structures, aggregates in the right locations in a distributed environment to deliver sub-second queries consistently across any BI tool or any data warehouse. And then the security and governance is key. So besides integrating with your single sign-on, those are table stakes. There needs to be even deeper controls around who can see what and what data when it comes to sensitive data elements like social security numbers and addresses and customer names. You got to have complete control over who gets to see what, and you got to have complete control over who gets to see what data. And that's very important, especially in a multi-tenant environment where you're dealing with, maybe dealing with a third party, where that third party data needs to be siloed without you having to silo it in your data warehouse. So what do we do? That's how we do it, and we do that for a lot of these customers. So you can see that there's a great sort of sampling here of some great financial services, healthcare, retail, and manufacturing customers. And they were all looking to solve those problems of how do I get a single source of truth? How do I migrate to the cloud without disrupting all of my downstream users and having to retool all those analytical systems? How do I make sense of multiple BI tools, multiple AI tools, but still being able to have the same data without moving it? How do I make it fast and be able to deliver data to the business instantly rather than in days, weeks, or months? So, so these are some of the things that we do for particular customers. So just to call out a few that are on AWS, like Koch Industries, for example, with Redshift, improved their query performance by over 40x. We have a great example like Tyson Foods, who actually migrated to Redshift from on-prem Hadoop, and they did that with AtScale in one click by changing changing their data warehouse connection and AtScale from their on-prem premise Hadoop cluster to Redshift, and voila, they were in the cloud. And you can see there's a lot of different examples here of how we allow customers not just to get quicker access to data, but to reduce their costs, like Bowl.com did by 91% in BigQuery's case, and in Google's case. And then also just allowing them to hold more data, like Wayfair being able to retain 5x their data, to being able to allow Home Depot to serve 10 times more analysts for the same cost. So we make things fast, we make things cheaper, and we make them more ubiquitous and quicker, with leaving the decision up to you about where you store your data, but not complicating the lives of your business analysts or data scientists. So where does AtScale fit in the AWS landscape? This is, Databricks has been sort of coining the term a lake house. And I kind of like that term, but I think it's not quite complete enough. But if you're purely in an AWS cloud, you can probably see that you have your data lake in S3. That's where all your files will land. You probably have some kind of a ETL engine. It might be EMR. It might be some of the new tools like Matillion, for example, but you're probably feeding a Redshift or a Snowflake data warehouse. But you also have data that's just in files that may not be worthy to load in a data warehouse. Well, with AtScale, as the layer that sits in between the consumers of the data, whether they be your Tableau users, whether they be your Jupyter notebooks, whether they be your custom applications, we're that sort of single API. We're that doorway that will allow your users to consume without having to know where that data is. So if you have detailed granular data that you need to be able to allow your analysts to explore, but you don't know yet whether you want to commit it to a warehouse, AtScale can make that happen through great tools like Spectrum and Athena. And I'm actually going to show you this today. I'm going to show you how we use Spectrum and query S3 files directly through AtScale. I'm also going to show you how we query a Redshift data warehouse today, and you'll see that. But really what's not on this picture is, what about your on-prem data warehouses? So I'm also going to show you how we can query data in Teradata on-prem, and all that is available and blended in a single virtual cube so that your users don't even have to worry about where data is or how to make it join. Of course, you can integrate this with great enterprise data catalogs that AtScale shares metadata with to really truly give you a great, not just governance platform and workflow, but also an enforcer of that governance. So we can enforce everything, right? Because we're the man in the middle here. Every query goes through AtScale. So we can enforce and govern all access to that data, make it fast, regardless of the consumption method, and do it all safely with any granularity of data. Data that's raw, data that's prepped, or anything in between. So how does AtScale do it all? Well, this is the components of our platform right here in the middle. So of course, we're connecting the consumers to their underlying data and data platforms. And so we do that through a visual modeler, and I'm going to show you that today. We call it Design Center. And in that modeler, this is how we actually create the semantic view we call virtual cubes that allow you to create a semantic layer for those consumers that you see up above. Now, those consumers can talk in any language they want. Typically, the newer tools like Tableau and Looker, for example, are using SQL, and we support that. But also, the most ubiquitous tool, Excel, speaks XMLA and MDX. We also support that. And in my demo today, I'm going to show you how we can connect through Tableau, which is SQL mode, and then I'm also going to show you how we connect Excel and Power BI through MDX mode. So you can see that we use the same exact semantic layer regardless of the tool being used. So how do we actually do it? Well, we do it with a full multi-dimensional engine. So rather than having to abandon what customers and your users really like, measures and dimensions and hierarchies, and go to straight SQL and force your users to become data engineers, they can consume from a fully multi-dimensional, multi-pass engine. It's an SSAS, SQL Server Analysis Services drop-in replacement. That means anything that you can do in SSAS, you can do in AtScale, but AtScale. The federated query engine allows you to join data across these different data platforms. So if you have product data and Teradata on-prem, you have sales data or web traffic in the cloud in Redshift or in S3, you can blend that data together without having to move it. And we'll do that automatically under the surface. This is no good if it's not fast enough. We're talking about BI workloads here. And that means queries under 5 seconds or forget about it. We have what we call our acceleration structures, which is using our AI engine to actually create aggregations in the appropriate locations on those data platforms. We do not ingest data. We do not have our own database. This is pure pass-through. We're using your data platforms that you've invested in, that you've secured, and that you've scaled, and we're using those data platforms to do the heavy lifting. So all we're doing is we're helping them out. So rather than running the same query multiple times on the atomic level data, we'll be smart enough to create an aggregation based on those user queries and those patterns so that we can make that IO and that time it takes to query that data minuscule. And that's really the key to how we solve the problem of concurrency, how we solve the problem of speed, and how we solve the problem of cost is by really dramatically reducing the amount of IO that we cause and we make that happens on your big data platforms. So what does that mean to you? I would encourage you to go to our website and download our TPC-DS 10 terabyte benchmark. These are the results for Redshift. And you can see that we also have ran the benchmark against Snowflake and against Google BigQuery. And we did this with TPC-DS. That's the TPC is the open source council that hosts data and queries for running benchmarks. DS stands for decision support. So this is a 10 terabyte benchmark where we ran a series of TPC-DS queries, which is basically based on a retail type of data warehouse, where we're talking about 28 billion rows in the largest fact table and 65 million rows in the largest dimension table. And these are the results. With AtScale, we improved performance on Redshift by 12.5 times. For user concurrency, we increased the concurrency with the same hardware footprint by 61x. That means the queries were 61 times faster with 61 times the load with the same hardware. And we're able to reduce the cost of that cluster by over 2.5 times. And all, by the way, we made the complexity of actually running those queries 76% less complex. That means we took out a bunch of extra calculations and extra repetitive SQL and joins so that you could actually query that data in a very simple interface without having to be a data engineer. So this is what we're going to do for our demo today. Enough of the slides. I'm gonna, and I hinted to this, I'm gonna query and query the data with Tableau, Power BI, and Excel through the AtScale platform. So the AtScale platform is sitting here, actually running on my machine, but I have data in the cloud in AWS. I have my web sales data, so it's my sales data. It's for a web store stored in Redshift. My orders data, though, is straight in an S3 bucket in a CSV file. I'll show you that. And then I have my product catalog data on-prem in a Teradata data warehouse. So I'm going to show you how we're going to be able to blend all that data in a single virtual cube and query that live. So today, in today's demo, I'm going to be really wearing the hat of two different personas. My first persona is going to be that of a data owner or a data publisher. And so using AtScale Design Center, I'm going to design that virtual cube that is going to access those three different sources of data. And then I'm going to publish that virtual cube. Then I'm going to take that hat off as a data owner, and I'm going to become a data consumer as a business analyst. And I'm going to show you how I'm going to be able to explore that data with a number of different tools. Okay, let's go. So before we start, I want to show you, just show you what it looks like when it's done. Okay, so this is what we call Design Center. Design Center has what we call a canvas. That's what you see in the middle. And then what you see on the right-hand side, you see these different panels for how we actually define these virtual cubes. What you see here in the preview is what the user is going to see in their BI tool. And they're going to see the same thing in their BI tool. What you see over here, of course, is our data assets. So these could be tables or files in the case of Redshift Spectrum. And I can go ahead and model these. These orange lines are all relationships for how I relate these different files together. We're not doing any ETL here. All we're doing is defining a model, and AtScale is going to do any transformations on the fly. So then how does that look like in Tableau? Well, here you see in Tableau, what you see is what you get. There's my customer attributes folder, data attributes, orders, and product attributes, and the like. And you can see there's all my sales metrics. And you can see in the case of my product attributes, I actually have a product hierarchy. You can see that hierarchy is fully exploded or fully revealed. So you can do true OLAP in SQL mode in Tableau. So let's go ahead and let's rebuild this view. I'm going to rebuild this on the fly. So when we talked about one of our value propositions, which is our value drivers, is accelerating data-driven insights. That means that you need to be able to take raw data and make it consumable by an analyst as quickly as possible. So I'm going to do that right now in about 8 minutes. So let's come back to my main project here, and I'm going to go ahead and create a new virtual cube, and I'm going to call it demo today. By creating a new virtual cube, I'm going to actually launch into my canvas here. And what you see is I have my blank canvas, and right now I don't have any dimensions and measures. So I'm going to start to actually integrate data onto my canvas by pulling up my data sources tab. So here I have Teradata and Redshift Data Warehouse. I did this just in my settings by defining the data warehouse. So any data warehouses that are available to me, there's no restriction on the number, are going to show up right here. In the case of Redshift, I'm going to start with my web sales data because I know I have in my AS Adventure schema, I know I have a sales log. My sales log is the data from my web store in a log file in a table that's been loaded in Redshift. So how do I know it's Redshift? You can see it's Redshift Data Warehouse there. You can see here's all the data. I didn't need to tell AtScale about this. We're using JDBC to read the underlying data catalog. So there's no reason to repeat that information in AtScale. We discover it automatically. If I double click sales log, this brings up what we call our dataset composer view. So here you see is a sample of our data fields. You can see there's a number of different fields here. This is just the raw data that's in this case in my Redshift table. You can also see I have, really I have some dates that are numbers, some dates that are strings. I got comma separated values here. These are the key value pairs. I have some junk in here in my sales reason field. Like I have some that have nulls in them. So with AtScale, I can go ahead and create transformations. Like for example, I'm going to do a replace transformation and replace all my nulls with unknown, for example. And so by doing that, that's going to create a virtual column. You can see there's my transformation. So if I go ahead and say create that, it'll create that virtual column that I can use that has now cleansed my data. I can also create new virtual columns from scratch. So let's create a sales tax, and I can write a formula with my helper here by taking sales amount times 8.5%. Now this is important because we're going to pass this formula straight through to Redshift in this case. So anything you can do in Redshift, you can do in AtScale. We're not going to force you to learn a new syntax. If you're used to the syntax for your data warehouse, you can use that right here. And in doing so, I now have sales tax, which you see over here on the right, and there's my computation. So let's come back now to my main canvas here, and let's start to add that. You'll see sales tax is now a calculated column in what we call a data set. So this is now something that is reusable across virtual cubes. So the way I create a measure, let's take that sales tax and drop it in. So what did we just create? I'll just go ahead and click save. And what you see here is you see sales tax is now part of my virtual cube. So let's go a little bit slower. Let's add order quantity, for example. Okay, so order quantity, what did AtScale do? It normalized the name. So it's not just some database field. And we also chose an aggregation type. So this is where OLAP and the multidimensional engine kicks in. By doing this, I can have a complete multidimensional engine and allow AtScale to do all this work server side without having to have a BI platform. Let's take sales amount and let's do that. Let's take my customer key. Where's my customer key? Here it is. And let's change that. And let's count my distinct customers. I couldn't do this at Yahoo. It was very frustrating. I couldn't count my unique cookies because it was too big to fit in analysis services. With AtScale, I can go ahead and choose it right here, and we're going to do that and do that calculation at scale. So there you go. There's some four good measures that I can start with. So I don't have any dimensions yet. So how does that work with AtScale? Well, I'm going to start with creating and using some existing dimensions from my library, and then I'll show you how I can create a new dimension from scratch. So the library is a really important concept because this allows us and allows your users, allows your authors to be able to reuse and conform data. Like how many times, let's just go ahead and pull these on. How many times have you had date dimensions, especially if you're a retailer, where they can be very complicated and it's very, very important that you report on and roll up your data the same way across all BI tools. Or customer data. How many times do you have different customer data that you repeat across all these different BI tools? Or product data. So I went ahead and pulled those onto my canvas. So let's see what happened here. You see that my date dimension is in Redshift, so is my customer dimension. But if you notice that my product dimension is actually residing on Teradata. So why is that? So let me double click on that. And there you can see that the dim product table, and here's the product hierarchy been defined in the dimension canvas. If I go ahead and wrangle that, this data now is that query actually was issued against my on-prem Teradata data warehouse. So it's that simple to be able to integrate data from different sources here. It really is super easy. Okay, so so let's go back and let's wire these dimensions up. And what I mean by wiring them up is that I have my fact data here, and now I want to relate it to my particular dimensions. So let's watch what happens. First of all, let's take my customer key and let's hook it up to my customer dimension. All I got to do is click save. Now watch what happened. You see how a folder for customer attributes was added? And you can see that I have all my information about my customers, including their gender, as well as I have a hierarchy, two hierarchies on geography. One that's at the city level and one that goes all the way down to the zip code level. So why did that happen? That happened is because my customer dimension actually has an embedded model that includes geography as a dimension inside of it. So while it looks very simple, it's actually a pretty sophisticated dimension that has a lot of reuse even within it. Let's take my product key and link that up. And then what did it do here? Well, you can see that my product hierarchy, it actually inherited the product hierarchy as you see in the dimension. So I didn't have to reproduce that or recode that. That's going to be consistent for anybody who uses it and that easy to make it work. What about dates? Well, you can see in my hierarchies here, I have some retail 445 hierarchies. I got my custom PP445. This is all retail type of jargon. But what this means is that I can create and use dimensions and date dimensions and roll it up any way I want, whether it's a custom roll up, which a lot of customers have, or whether it's just a standard roll up. So to use that then, I could take my order date key, I can just connect it up. In this case, I'll connect it up to that I hierarchy. I'll give it a prefix called order. And now what I have is, I now have my order date hierarchy here. And you notice that instead of year, quarter, month, and day, it says order year, order quarter, order year, and day. So what that means is that we call it a role-playing dimension, which means if I take the same thing, let's see, let's do ship date. And I say ship instead. Now I have a ship date dimension in addition to my order date dimension, as you can see down here. So that's as simple as it is. That's how I can use and reuse role-playing dimensions and create a pretty sophisticated cube at this point with little or no work. So let's go back to my raw data view again on my sales log. And you remember we had we had some data that was nested in key value pairs. So in AtScale, we actually designed this platform to work with today's data. Data is not in rows and columns anymore. It's in JSON, it's in XML, it's in key value pairs and structs and arrays. And AtScale can understand that and use that as is. So I'm gonna take, in this case, my product info field, which has attributes about my products, color, size, and weight, and style, and I'm gonna turn those into dimensions that I can report on. So how do I do that? I just go back to my canvas here, click on that product info field. We recognize it as a mapped column, and we can just add in the keys of that map, color and style. And then those are now become virtual columns in my sales log data set. To make them dimensions, all I need to do is just pop them in my dimension pane over here. And voila, now I have color and style as dimensions I can report on in my virtual cube. One extra thing I actually forgot about to mention here. What about my orders? So in my orders, what I ended up doing is that I ended up creating, here's my orders S3 bucket. So it's my S3 bucket, and there I have a dim order CSV file. So let's click on that, and let's just say, okay, shoot, I have to relog in. Okay, I'm not gonna do that, but if I were to look at that, it's just CSV data. So what I ended up doing to actually use that CSV data is all I had to do with using Amazon Spectrum is all I needed to do was just to create this external table called dim order. And with that external table referencing that S3 bucket, that's all I needed to do. And so now that external table is now available to AtScale. And with AtScale, I'm able to model it. Okay, so that's how I'm able to do Teradata. I'm able to do S3, and I'm able to do Redshift data warehouse all in one go here. So how do I make this new demo cube available to the world? We have this step we call publishing. See, before I publish it, let me do one more thing. Let's go to my demo, and I'm gonna show you some of the security features. So I can say, for example, I'm not going to grant access to all my users. In particular, Joe Tableau has I only want Joe Tableau to have discover permissions on this new virtual cube I just made. So I'm just going to go ahead and set that with as a security attribute of the demo virtual cube. And I'm going to show you how we can play with that later. So let's go ahead now and let's go and publish it. So publishing it, basically, I can publish different versions of that virtual cube, but once published, now I have my demo virtual cube that's ready to go. So let's go ahead and let's explore that first with Tableau. So with Tableau, I'm gonna go ahead and pull this up. We automatically create a Tableau data source that's gonna be pointing to that new demo virtual cube, which I just created. So let's go ahead and do that. Let's log in. Of course, I'm using my single sign-on, so whatever user I'm logged in as is going to be the user who's executing the query on the data warehouse. So there you go. There's my product metrics. You saw that I added those 4 metrics. And then there's my hierarchies and my dimensions. So this is a live connection. So if I go to my data source tab here for a second, I want to show you that it's a live connection. We're not dealing with an extract here. And you can see that this is how the demo virtual cube appears to Tableau. It appears as a single entity. So now I can go ahead and do an order quantity. That was just a live query. And let's run a federated query actually. So remember, my product information is actually in Teradata. So what AtScale just did that fast is it actually ran a federated query where it had to join data in the product information in Teradata with the web sales information that was in my Redshift data warehouse. Okay, let's keep going. Remember, color and style, those are my key value pairs in that nested field. Well, all I have to do is do that, and there you go. There's my breakdown by product. You notice there's a lot of nulls because a lot of products don't have color as an attribute. In a traditional modeling sense, I would have to create a column and a dimension table where most of my products don't even have color as an attribute. It'd be just a very sparse column. What a waste of space. Okay, let's go and let's go back real quickly before we move on and see what was happening here behind the scenes. So let's go to my queries dialog here. So in AtScale, every single query is logged and audited. So that last query I did with color, here's where you see it. There's my color query. This is the query that was incoming into AtScale that we intercepted. And of course, we wrote this query going outbound. And you can see it's a quite complicated query because we're going to do all that complex SQL for you, in this case against the Redshift dialect. So then what happened before that query? Well, remember, we ran a query that was actually federated. So how did that work? Well, you can see this is the combined query that we ran against our compute cluster. That's our federation engine. But the actual individual data came from Teradata. There's that query. And Redshift, and there's that query. So AtScale automatically generated and sent queries to those respective warehouses, and all that automatically just based on that model I just defined. Okay, so I just ran that query. Let me hit refresh again and see how that works. I'm just forcing it to refresh here in AtScale in Tableau. So that actually ran a query. So let's refresh this. You saw that that query, that original color query, ran fast, but this time, what did it do? This time it ran even faster. And why? Because this time it used an aggregate table. So in between the time that I was explaining that, AtScale was busy behind the scenes, actually already optimizing that query. So rather than querying millions of rows, if I click on this aggregate table, you can see I only had to query 8 rows because there's only 8 colors, including the null. And that is the key for how we deliver scale, concurrency, and lower costs for your AWS environment. We don't do anything twice. It's not necessary. We're going to optimize and do that automatically for our users. Okay, so what does this look like in other BI tools? So you saw it in Tableau. Let's go ahead and let's look at what it would look like in Excel. So we'll start there first. So how do we integrate with Excel? We're not going to dump data into Excel. That's not secure, and that's also, Excel is not made to be a database. What we're going to do is we're going to create a live query using the built-in SQL Server Analysis Services driver. So there's nothing to install for your Excel clients. There's no such thing as an AtScale driver because we're going to use the drivers that come with your BI tools. So here you can see, there's my demo virtual cube. So all I need to do is to go ahead, I'm going to create a live pivot table here by clicking pivot chart. And by doing so, you're going to see there's my demo and there's my demo virtual cube that we just created. And if I click on order quantity and I click on color, of course, I'm going to have the same exact answer that I got in Tableau, but this time I have it in Excel. Same semantic layer, same security rules, same answers every time, same performance. Because if I come back now to AtScale and go back to my query screen again, let's see what happened with that query. Well, this time we intercepted an MDX query. This is the language that Excel speaks with a live pivot table. And what you can see here is that we reuse that same exact aggregate that we saw and used in Tableau. That's power and that's efficiency. And that's how we can support multiple clients. We can do the same thing with a Power BI interface. So in Power BI, if I go and I click on the Get Data button here, this will pull up my, my connection screen. And what you see here under Database is that you see AtScale cubes show up as a first line connector. So we've worked with Microsoft to actually create an amazing experience here that is a direct query experience. So notice how I chose direct query. We're not going to import data into Power BI. That would be data movement. That would be insecure and unsafe, and it would also limit the scale for what I can do. Instead, we're doing a live query against the AtScale virtual cube on Redshift, and there's my demo cube. And all I have to do is click load, and now I'm going to be able to create a Power BI direct query workbook here, where the data is being queried live against AtScale using the same techniques you saw with Excel and you saw with Tableau. I'm going to get the same answer, and again, with the same security attributes. So let's go ahead and let's look at my metadata here and see what we got. So here's the same set of metadata that you saw before. Let's look at order quantity, for example. So you see the same thing, order quantity. And let's look at color, for example. And look at color. And voila, that's automatically going to send a query to Power BI is going to send a query to AtScale. And there you go. Same answer again and same security attributes. So there you saw it. Oh, there's one more thing I can do. What if I had a custom application? So forget about consuming via a BI tool. Let's talk about consuming via a Jupyter Notebook for my data science workloads. Or let's say I have an application that I want to query. Let's go back and let's pull one of these queries off that we just saw here. And let's pull off that. Let's pull off one of those queries that we saw that was SQL, not that one. And I'm going to show you here how I'm going to actually create a live query against, here we go, let's do this query. Against, in this case, I'm going to go my DB Visualizer tool. This is just a little JDBC tool. So I can come into this and first of all, what does AtScale look like just to a JDBC client? Well, let's go back here. I'm going to reconnect or refresh. And so I'm talking to my AtScale instance here. Now you see my Sales Insights, Redshift, that's my project in AtScale. And then now you see the demo and internet sales cube. That demo is now looks like a table to JDBC. So there is my virtual cube. And that means I can run a query, just a SQL query with JDBC. And again, I get the same exact answer that I got in my BI tools. And now I'm getting it in an application that can speak JDBC, ODBC, or XMLA. Ultimate flexibility for a single semantic layer. Okay, now what about agility? How fast, how hard is it to change that virtual cube now that I created it? Well, let's go back to my demo cube. You know, the whole reason when we say we want to accelerate the time to insights, we mean it. So let's go and take my product info, for example, and let's add a new column for size, because I want to look at my product distribution, my product sales by product size. And I'll pull that in as a virtual dimension. So there's no dimension table that we had to create, no ETL. All I need to do to make that live so I can see that new virtual column, that new virtual dimension, is publish it. I'm going to come back to Tableau for a second here. Now watch what I have. Remember, I have color and style. If I just go ahead and click refresh and tell Tableau that there's something new, there's my size, my size dimension. That's a live query. I just ran against size. I'll get rid of all those, exclude all those nulls. And now I have a view in Tableau of all my product distribution by size and by color. Again, true agility there. Okay, so what about some security and security attributes? There's too much to go into right now for everything. We have row level security, of course, and we have what we call perspectives. I can't show you it all because we're running out of time, but let me show you perspectives. So what you can see over here is that we have, for example, I have customer PII in here. I have names and addresses in here. So what if I wanted to exclude that? So I want some customers or some of my users to be able to see that information because they need it. So the demo cube will be able to be visible and those columns will be visible. But what I can do is I can actually create a new perspective. And a new perspective, I'll call it demo no PII. And so how do I work this? Well, I can just come to my virtual cube. I can say, you know what, for my customer hierarchy, I don't want to show my customer name. And I definitely don't want to show last name and first name. So all I need to do is save that. And now that's now a new perspective. So now if I come over to my preview screen over here, and I go ahead and click that, click a refresh here, and click that drop down, what I'm going to see is I'm going to see my perspective for my no PII. So here it is, demo no PII. So let's just open that up. And then what you see here is my customer attributes. Now you notice there's no product, there's no customer name, first name, last name, or complete name. So now demo no PII, I can now publish that and make that available to my users and assign groups and users so that they only can see that virtual cube or that perspective versus the full perspective. So then how do I actually make that data available to my consumers? Well, this is new to AtScale. We call it the virtual cube catalog. So, so remember I set that setting where I said discover was the only permission for this demo cube. So let me show you how that works. I'm going to log out as admin, and I'm going to log back in as Joe Tableau. So I'm logging in to our endpoint as Joe Tableau. Now what you see over here is that Joe Tableau only sees two menus, a support menu and the catalog. And you can see there's my demo, and you can see there's a request button next to them. I can also see what's in these virtual cubes. So if I'm a consumer, I'm that end consumer, I can decide whether or not I want to request access to that virtual cube. So now that I've requested access, you notice it's pending. Let me go and log back out and log back in as my administrator here. And then what you'll see is that on this little bell over here, there's a new notification. That new notification said that Joe Tableau has requested query permissions on my cube. So I can go ahead and review that permission and grant it, or I can deny that user. I'll deny, and that user will get that notification for query. So that's how we can complete that loop of communication between the designer of those virtual cubes, the data owner, and that business analyst or data scientist who wants to consume. So those are some of the key. Those are some of the sort of the key things that we can do with AtScale today. Just to come back and sort of review what we saw here. What we saw here is really the ability to accelerate our data-driven decisions at scale. You saw that when we instantly were able to produce a new virtual cube and query it, and we were able to change it by adding size to that virtual cube. I showed you how we reduced the amount of I/O on the underlying system, which reduces the cost. You saw how less complex it was because we joined 3 different data sources in one virtual cube, so our users didn't have to understand that. You saw how we had one consistent, compliant view of that data, one single source of truth, because I showed you how we consume that in Tableau. I showed you Power BI, Excel, and just a regular old JDBC tool. And I showed you how we reduce risks by actually applying security and security rules through perspectives. And by hiding different attributes depending on your users and groups and roles. And you saw that we did that with intelligent data virtualization by combining multiple data sources. You saw that single semantic layer, that universal semantic layer in action. You saw our autonomous data engineering working live by creating aggregates on the respective data sources automatically. And you saw how our security and governance engine worked with your systems. So that's all we have for today. I want to thank you for attending and for listening. And please come to our website if you'd like to see more information about different customer use cases, as well as our benchmark. And if you want to request a personal demo, we would love to show you that and answer all your questions live. So thanks, Carol and Laurel, back to you.
Yeah, thank you, Dave. You were very thorough today. We had one question, and that was, can you share the slides? And the answer to that is yes. There'll be a follow-up email to this webinar, and we will share the slides, and we will also provide a link to the benchmark results for Redshift for everybody on the webinar today. Thank you again. Bye-bye.